On the calm, freezing morning of February 15th, 2013, millions of people in the Russian region of the Ural Mountains were waking up, drinking coffee, and heading to work. It was a completely ordinary Friday morning. The sun was just starting to peek over the horizon, and commuters were navigating icy streets with their car dashcams recording every turn. Nobody knew that 45 miles up in the cold upper atmosphere, a cosmic assassin was silently racing toward them at hypervelocity. Welcome back to Cosmic Clueless. Today we are reliving the most documented, dramatic, and explosive asteroid impact in modern human history, the Chelyabinsk Meteor event. This was the day space literally smashed into our backyard without a single warning from NASA, space agencies, or orbital telescopes. So buckle up, put on your safety goggles, and let us watch what happens when an ancient space rock collides with the atmosphere and our poor, unsuspecting Stickman proxy. To understand how close humanity came to a localized disaster, we have to look at the meteor's origins. Long before it hit Earth, this celestial giant was an ancient space rock floating in the Apollo asteroid belt between Mars and Jupiter. It was composed mostly of silicate minerals, iron, and nickel, a heavy, dense, stony asteroid that had been orbiting the Sun undisturbed for over 4 billion years. But millions of years ago, a slight gravitational nudge from Jupiter nudged the rock off course, sending it into an elliptical orbit that intersected Earth's path. Fast forward to February 2013. The asteroid measured roughly 60 feet across, about the size of a 6-story building, and weighed an astounding 12,000 metric tons. That is heavier than the Eiffel Tower, all packed into a solid, jagged boulder hurtling through the vacuum of space. At exactly 9:20 a.m. local time, the space rock hit the outer layers of Earth's atmosphere at a mind-boggling speed of over 40,000 miles per hour. That is more than 60 times the speed of sound. At that velocity, the air molecules in front of the asteroid simply could not move out of the way fast enough. As the rock rammed into the atmosphere, a massive cushion of air compressed in front of it. High school physics teaches us that compressing gas generates extreme heat. The temperature in front of the rushing meteor skyrocketed to over 15,000 degrees Fahrenheit, hotter than the surface of the sun. The extreme heat vaporized the rock's outer shell, turning it into a glowing trail of superheated plasma that cut across the morning sky like a blazing sword. Now, picture our Stickman proxy driving his tiny Stickman sedan to work that morning. He looks up at the sky, sees a brilliant white streak, and assumes it is just a super-fast jet plane. But suddenly, the streak expands into a blinding, roaring fireball that glows 30 times brighter than the sun. The light is so intense that the shadow of our Stickman's car is instantly burned onto the pavement behind him. Confused and blinded, our Stickman slams on the brakes, steps out of the car, and takes off his sunglasses to stare directly at the exploding sun in the sky. Classic Stickman situational awareness. Back in the real world, residents across a 300-mile radius stood in absolute awe. People ran to their apartment windows, pulled out their cell phones, and stared out at the giant double smoke trail left across the sky. Drivers pulled over, mesmerized by the blinding light that cast long, unnatural shadows across the snow-covered city. For 90 agonizing seconds, there was absolute silence. People thought it was a military test, a missile launch, or an alien spacecraft crashing. But what no one realized was that light travels at 186,000 miles per second, while sound travels at a much slower speed. The visual spectacle had already happened, but the giant air blast generated by the atmospheric explosion was quietly racing toward the city's surface at supersonic speeds. For nearly 2 minutes after the blinding flash, the city of Chelyabinsk was eerily quiet. People stood by their windows, filming the massive twin vapor trails stretching across the freezing sky, entirely unaware of the invisible wall of compressed air racing toward them at over 700 miles per hour. Then, the shockwave slammed into the ground. A series of thunderous, apocalyptic sonic booms echoed across the region, shaking the very foundations of the city. The pressure blast hit Chelyabinsk with the force of nearly 500 kilotons of TNT, roughly 30 times more powerful than the atomic bomb dropped on Hiroshima. The sudden pressure jump pulverized thousands of windows across 6 entire cities simultaneously. Double-paned glass windows in apartments, schools, and factories imploded inward, showering rooms in sharp flying glass shards. Doors were ripped off their hinges, ceilings collapsed, and car alarms went off in unison across hundreds of square miles. Over 1,500 people were injured in a matter of seconds, mostly from flying glass and debris, as they stood right by the windows watching the fireball. Why did the meteor explode in the air instead of hitting the ground like a giant missile? This comes down to a fascinating physics phenomenon known as ram pressure. As the stony asteroid plunged deeper into the denser layers of the atmosphere around 15 miles above the surface, the enormous pressure of the compressed air in front of it became too much for the rock to handle. The extreme air resistance forced its way into microfractures inside the asteroid. Within milliseconds, the giant space boulder flattened out like a pancake, cracked under the immense aerodynamic stress, and shattered in a catastrophic thermal explosion known as a bolide airburst. The asteroid essentially converted all of its massive kinetic energy into light, heat, and raw mechanical blast waves in less than a single second. Now, picture our Stickman proxy during this exact moment of impact. He is standing right next to a giant glass display window of a local pastry shop, holding a freshly baked donut, admiring the pretty glowing trail in the sky. Suddenly, the supersonic shockwave hits. The storefront glass detonates into a million tiny crystals. The blast wave blows off his Stickman toupee, knocks his pants completely off, and launches him backwards into a mountain of powdered sugar and cream puffs. He emerges covered in white powder, holding nothing but a broken donut ring, completely bewildered. Classic Stickman bad luck. But while the shockwave caused massive damage across the region, the world was equally shocked by the legendary ice-cold reactions of the local citizens recorded on dashcams. Thanks to Russian insurance regulations, almost every car on the road was equipped with a windshield camera. Within hours, YouTube was flooded with incredible high-definition footage of the meteor from hundreds of different angles. In many videos, drivers did not even slam on the brakes or scream when a second sun lit up the sky. They simply adjusted their sun visors, flipped the radio station, and kept driving through the snow, as if giant exploding space rocks were a daily morning routine. Meanwhile, the surviving fragments of the meteor, now slowed down by atmospheric drag, began falling back down to Earth in a cold process known as dark flight. Deprived of their blazing plasma trails, hundreds of small, blackened space stones rained down across the snowy Ural countryside. The main body of the asteroid, a colossal chunk weighing over 1,200 pounds, crashed directly into the frozen surface of Lake Chebarkul. It punched a clean, perfectly circular 20-foot hole right through the thick ice, sending a geyser of freezing water, mud, and slush into the cold morning air. Overnight, a quiet, icy lake turned into ground zero for scientists, military divers, meteorite hunters, and adventurers from around the world, all hunting for a piece of the ancient visitor from space. The moment news spread about a giant space rock punching a hole through the ice of Lake Chebarkul, a modern-day gold rush hit the Ural Mountains. Scientists, professional meteorite hunters, and local residents rushed to the lake, wading through deep snow with metal detectors, strong magnets, and plastic baggies. Tiny pea-sized fragments of the meteor, covered in a dark, glassy fusion crust created during its flaming entry through the atmosphere, were scattered across the snowfields. Within days, these tiny space pebbles were selling online for hundreds, sometimes thousands of dollars. The simple black rock found on a frozen field suddenly became more valuable than its weight in pure silver. But the real treasure was resting over 60 feet down, at the murky bottom of Lake Chebarkul, buried deep in thick, freezing silt. A team of professional deep-sea divers spent months battling icy waters, zero visibility, and freezing temperatures to retrieve the main fragment. In October 2013, 8 months after the explosion, the divers successfully hooked ropes around a massive, mud-covered boulder and pulled it up to the surface. As they placed the cosmic monster on a heavy-duty industrial scale, the metal plate groaned under the weight. The scale registered an astounding 1,300 pounds before the digital display shattered right on the spot. Today, this colossal chunk of space history sits proudly under a glass dome at the State Museum of History in Chelyabinsk. Now, picture our Stickman proxy working as a museum security guard, standing duty right next to the massive meteorite display. He decides to test if the space rock is still radioactive or magnetic. He pulls out a giant neodymium industrial magnet, steps too close to the glass, and the magnet snaps onto the meteorite with terrifying force. The 600-kilogram space rock gets dragged off its pedestal, tips over, and flattens our Stickman like a paper pancake against the museum floor. His paper-thin Stickman hand reaches out from under the rock, weakly waving a tiny white flag. Classic museum protocol. On a serious note, the Chelyabinsk event was a massive wake-up call for the entire planet Earth. Before February 2013, space agencies around the world were primarily focused on tracking massive, kilometer-wide asteroids, the kind of planet killers that wiped out the dinosaurs 66 million years ago. Scientists assumed smaller rocks under 100 feet across would simply burn up harmlessly in the upper atmosphere. Chelyabinsk proved that even a relatively small 60-foot asteroid can release the energy of 30 atomic bombs, blow out millions of square feet of glass, collapse buildings, and injure 1,500 people without ever touching the ground. What made Chelyabinsk even more terrifying was the direction it came from. The space rock approached Earth directly from the direction of the bright morning sun. Because ground-based optical telescopes cannot look toward the sun without being blinded by intense glare, the asteroid remained completely invisible right up until the second it slammed into our atmosphere. Following the Chelyabinsk explosion, global space agencies like NASA and ESA drastically upgraded their planetary defense programs. New space telescopes were funded, automated sky tracking systems like Atlas were deployed, and missions like NASA's DART were launched to test whether we can crash a spacecraft into an approaching asteroid to knock it off course. The Chelyabinsk Meteor reminded us that our peaceful blue planet floats in a cosmic shooting gallery surrounded by millions of ancient space rocks crossing our orbital path. The universe throws rocks at us every single day. Most are tiny grains of sand that burn up as shooting stars, but every once in a while, space reminds us who is really in charge. So, what would you do if a bright second sun suddenly lit up the sky on your morning commute? Would you pull out your phone, take cover under a desk, or just adjust your sun visor like a boss? If you enjoyed this journey through cosmic explosions, physics, and Stickman survival, smash that like button, subscribe to Cosmic Clueless, and drop a comment below. Watch the morning sky, stay away from glass windows, and we will see you in the next episode.